Okay, I just want to very quickly today to solve very quickly the assignment which you had for yesterday, and in order to make sure that you just you double check your work with me, that it makes sure that for tomorrow exam, for tomorrow quiz, if you have something similar, you know that what's going to be the right approach for it. Okay, then as a result, I'm just going to share my screen. I'm just going to just do very quickly. Please, in the meantime, if you have your notes from yesterday that you send it to me, have your notes next to yourself that you can just double check. It was a very easy, I should say, question, but make sure that you double check your answer with me. I do not just go as to many details which we had yesterday. Then that's good that you double check before we just move on. Then we just the next plan which we have for today. Then we jump into the end chapter questions, solve some of the most important ones. Then we get ready for tomorrow for the final test, not the final test, for the chapter review quiz then. Okay, now I have this one here. I'm just gonna just go one to share my whiteboard with you. Then we just move on. Then please, guys, remember, make sure that you have your notes from yesterday. Okay, let me maximize the window here. Let me also move this menu all the way up there. And now it seems that we are ready to get started. And let's see. What we are going to do today, we are going to then make sure that we are done before, I should say, before 11, because sharp 11, we are just going to do today our the first session for our math lab. That's, we call that AI laboratory. Okay, I'm just gonna just start with this one. It was the modeling which we did with the R of X, which R represents the revenue of the company. It becomes minus X squared plus 10X plus 30,000. Okay, that's the thing today. We are going to talk about this. We say that this is the model, which is the revenue, which is model. And as we saw from the course, we saw that, let's say, X is going to be the cost of one package, which we are going to talk about that. X is going to be the cost per package. Okay, although this model is not the realistic one, but let's go ahead and talk about, let's say, the maximum. We're going to discuss the thing that we're going to discuss today. We are going to talk about, I should say, the concept of the local maxima and local minima of the of this model. That's the plan which we have. And let's get started to just go to talk about the local minima and local maxima of this one. Okay. Now, the first thing that we do, you remember, the first thing is going to be what? If you remember from our previous slides, step number one is what? Is to find the spontaneous rate of change. For the spontaneous rate of change, for this one is going to be step number one for us. And that's essentially what we talked about that yesterday. And now I'm just going to go ahead to just find the spontaneous rate of change for this. But remember, you assume that in order to find the spontaneous rate of change, you know that if you want to say I in the instantaneous rate of change is essentially what we talked about that yesterday. we talked about a model. We said that it's going to be d of r of x. It means that the variations with respect to the variations of the revenue with respect to the variations of the cost per package, it decides, I should say, for instantaneous rate of change. And the thing that we talked about that yesterday, we came here and said that it's going to be a very easy thing. We said that in the R functions which we have here, that's the R functions which we have, we can write x plus delta x. Wherever we see x, we replace it with the x plus delta x minus r of x, minus r of x divided by delta x, which it seems that it is the variation, I should say, of our the x. Then we have delta x. We have the delta x, we push it goes to 0, and we know that you're gonna learn about that next year. We just put something, a kind of a symbol here, which we call that a limit. You're gonna talk about that, learn about that for the next year. But anyhow, if you just follow these instructions, you just go to the model which you have for the revenue of the company. Wherever you see the x, you replace it with x plus delta x, and you have your r of x. You simplify the terms. You just eliminate the similar terms which they have opposite signs. Then you simplify that, the delta x from the numerator with the denominator. Then with whatever you are left, you just put delta x equal to 0. That's the thing which you're going to do that yourself. But if you do that, at the end, you get the rate of change for the model which we have. It's going to be this. We say that d of dx of r of x, it becomes minus 2x plus 10. That's the model that you're expected to have from your answers on what the things which you have done. Now, the next step is going to be here. We just come here, say, okay, we take d of dx of r of x, which represents, I should say, the instantaneous rate of change. It means the sudden change of, I should say, of our model goes to 0. Then we just go ahead and we see that, okay, then we have minus 2x plus 10. It becomes 0. Then from here, we see that 2x is equal to 10. Then from here, we see that x is going to be $5. Because x represents the cost per package, then we just assign a unit for that, which means that it's going to be dollars or anything, because the total revenue, it's in the question, which it says that this is measured in terms of the dollars. Okay, we just have x equal to 5, and it means that we are done with step number 5, and we just go to the next page. We just go ahead, we just go with the step number 2. Step number 2 that we learned yesterday is that the full representation of the roots of the spontaneous rate of change model. Okay. It means that if we get x equal to 5, it means that the full representation is this, we call that x. We call that with the c. Oh, no, not this one. Let me just go ahead and I just call that, let's say, the critical point. We call that critical point. I'm just going to call this point, call that, for example, A, with sub and the C, which it means that the critical. Then we saw that it's going to be, it represents the x, which is the x of C, the critical point, which is the roots that we got, with respect to the R of x of C, which is going to be what? Which is going to be, I put 5 over here, and I just go back to the previous model that we have for the revenue. It's going to be this. Then it becomes minus 5 squared plus 10 times 5 plus 30,000. This is going to be, I should say, our critical point. You can simplify that further to get what is that going to be the level of, I should say, the exact value of this critical point that we are looking for. We have the XC is 5, and for this one, you can change it. It becomes 3,000, it becomes 50, it becomes 3,025, if I'm not mistaken. That's right. It becomes 50, it becomes 25. That's right. And now, the very last step, I didn't just plot this because I just wanted to just do this exercise without plotting in order to make sure that we learn the third step, which is going to be, I should say, and filling out this, I should say, this method that we're going to talk about that. We said that this one represents the left side and this one represents, I should say, the critical X. We say that, okay, now at this point, this one here, it represents XC equal to 5, and this one is going to be our X-axis. And now, okay, now here we have our step number 2 equation, which is minus 2x plus 10. Because we are looking for the slope of the tangent line of any points along the curve. And now we said that, okay, definitely the value of this function at xc equal to 5 is going to be 0. I'm going to put it 0. Then I'm just going to select one point here. I'm going to get something very close to that to see what is going to be the sign. I say that if I get a point and that point is going to be 0, I'm going to select a point here. I say x. It's a random point which I select. I call that xr. If I put 0, the value of my function here is going to give me a positive number because it becomes 0 times minus 2 times 5 becomes 0 plus 5. I have a positive number. And also, I just come here to the second part of this equation. I say, okay, for this one, I pick up a number. Okay, greater than 5, because you imagine that you were walking along the x-axis, then anywhere you are on the right side of this line, which represents x equal to 5, is greater than 5. Then imagine that, very simply, I pick up a random number, and this random number is going to be, let's say, 6, which 6 is greater than 5. Then what do I get at the end? Then I have 6. I replace it, put it here, becomes minus 2 times 6 becomes, let's say, minus 12. Minus 12 plus 5 becomes minus 7. Then I get a negative number here. Then you see that. The thing which happens is this. Then the point which we have here, based on the variations of the sign which is here, it means that, for example, this is positive. It means that, for example, you are, let's say, you are right now happy. And now here, this is negative. It means that what's going to happen to this point here, which is in the middle, is it the local maxima or local minima? And now it's the interpretation. So far, you are happy because the slope of, let's say, the tangent line is positive. If the slope of tangent line is positive, then you move on to the slope which is going to be negative. It means that what? For example, if that's going to be the coordinates, the slope of the tangent line is positive. It means that this is going to be anywhere along this line between these two quadrants. Then the slope becomes negative. It means that then it's going to be parallel to this line. Then what do you expect to be here? You see that it's set at the very top. Then it means that the point that we have here, which is xc is equal to 5, it's going to be a local maxima. Then what do I get at the result is that xc, which is the critical point, 5, it's essentially, it becomes the xm, which is the maximum point, which is 5 then. Then 0.5, it's our maximum, local maximum of that model then. And you can also plot it on the Desmos, you get the same result. You can also look at this, guys. If you always surprise, how can you remember this one? Look at this. When you have the smiley face, then as you move along the X, you lose your smiley face to a crying face. It means that you were at the top, that you were smiling because you were so high. Then when you are losing your money, losing your height, you frown. Then you become sad. Then it means that that point that you were smiley, then you get to the sad point is gonna be the maximum point because you feel bad that you are losing your money, you're losing height. Is it a good example to remember that for future?
Yes.
Yes? Then always when you see it's gonna be that trick then. But also I'm gonna come on the next page something as a trick to memorize it. Imagine now you are from, let's say, a very sad face, you end up with a smiley face at a point that it was a critical point for us. This point XC. You are from, I should say, a sad point, you are moving to a positive, I should say, a smiley point. It means that as you were moving along the x-axis, you were standing here, that you were losing, I should say, your money at this point. Suddenly at this point, you are moving up, and now you start to smile because you are earning more money. Then you see that whenever you have the sad face, then you change to the smiley face. This point, which is the opposite of the previous one which we had, it's gonna be the minimum, local minimum. Okay, you got that trick now? That it helps you for, I should say, for your future, I should say, assignments. From the smiley face, we just move to, let's say, sad face. Yeah, the smiley face, we go to a sad face. It means that we were at the top, then we just went down, then we were at the maximum point. Okay, guys, it was essentially a very, very brief representation of that exercise, although your notes that you had to prepare for me had to include more details and more steps as we did that. Okay, any questions, guys?
No.
No questions, Laura? Anki, how about you? I think you had the questions on this one. Is it gonna be enough? Does it resolve it? Anki?
Yeah.
Is it fine for you? I think you had a question on this problem. Are you fine now?
Sorry, sir. Can I say it again?
Anki?
Yeah. Can you speak loudly? No, sir.
I cannot hear you, Anki. Can you please speak? I think there's something wrong with my ear. Speak a little bit louder.
I mean, can you speak loudly? I can hear you too.
Sorry, what? Say that again?
Can you speak loudly? I can't hear you too.
Okay. Is it fine for you? Do you have any questions now? I think you have a question before.
Not now.
Is it fine now?
Yeah, I think I'm fine now. Yes, today's question.
Okay, awesome. And how about you? I should say Jasper and Sylvia. Both of you are fine?
Fine.
Yes, fine.
Awesome. So glad to hear it. Okay, although remember, your steps has to be more calculation. It has to involve more calculations. Now, I'm just going to share the screen before we just go for the break. We want to do something more fun. Okay, we have to be on time for our break because by sharp 11, we have to start our first math lab session then. Okay, now I hope everyone has the access to, everyone can see the screen which I have. I'm just going to, I should say, because it finished the chapter, I'm going to chapter number 2, the chapter review. I'm moving on. It's going to be page number 115. Just moving on to next chapter. Oh, where is the question? I just wanted to just give that to you. Oh, that's here. Okay, now. Okay, guys, for chapter review which we have, please go to page number, it's going to be page number, let me see, 117. It's going to be this page number 117. Okay. For this part, before we just go for the break, please guys, look at this exercise, exercise number F, 115. Please, before we go for the break, just go to that exercise. And the thing that we do is that we are looking for the local maxima or minimum. Maximum or minimum. To find for this equation, which is equation number F, if that point, which is -3 and also 9, 5, is a local maximum or local minimum. It's going to be page number 117, page 117. That's at page 117, exercise number F. This is going to be very good, interesting, I should say, exercise to wrap up all the things that we had. Then we move on to the next chapters to continue with more advanced stuff then. Is it fine with everyone? You got it in your, I should say, textbook?
Yes.
Awesome. Yes, is it fine? I can start it, and you please continue with me as I move along then. Okay, now I'm just gonna first of all write this equation on my screen. What did I have there? Okay. And now as I move on, you can just continue, I should say, your work, and I also do that the same as you do this. Okay, I put it up, push it up. I'm just going to go ahead to write the function which I have. The function which I have is this, is I have m of x. My function, this is called m. It's equal to 1/20 x cubed plus 2 times x squared minus 15x. the plan which I have is this. I just want to find v of m of x with respect to the changes of the x. I know that it's going to be this. It's going to be a line so long. Okay. Let me start by this smaller version. Okay. Now, the thing is that when we just want to find, I should say, this instantaneous rate of change for this function, you know that the thing which you have to do is this. You just come right away there and you say that, okay, wherever you see x in the function, you put it x plus delta x minus m of x over delta x. However, you have to push the delta x goes to 0. And we know that we put something here in order to make it look more concrete and complete. You get to learn about the limit in a year, but now in order to finish this, we said that it's going to be equal to, I'm going to write the huge line because it takes so many terms to be put there. That's why I have to just come here. At here, I just write this line from there because you will see that it has, no, I think, sorry, I just go ahead to just do that here. On the next line, we have to put more terms. Okay. The thing, I'm just going to start here. I just go to this equation. Wherever I see, I should say x, I put what? X plus delta x. It means that it becomes x plus delta x to the power 3 plus 2 times x plus delta x to the power 2 minus 15x. Then I have to say, okay, minus, the next terms is going to be this. The next term is going to be 1 over 20. It's going to be x cubed plus 2x squared minus 15x. And I know that put the delta x, the variations of my functions below. Then I'm not going to push, I should say, delta x to 0 at this stage. The thing which I have to do, as you will see this here, is that I have to simplify each term individually. I have to start from here to simplify that. Then from here, I have to simplify the smaller terms. This one, which has the power 3. This one, which has the power 2. And also, I'm going to, before I start, in order to make the things look simpler, 1 over 20 and 1 over 20, I'm going to factor from all these terms. Hello? Guys, can you hear me?
Yes.
Guys, it seems that there is something wrong, I should say, with my laptop. I lost, I should say, my screen. It seems that it's vanished. My screen is vanished. I don't know what has happened to that. Give me a second to see how can I bring my screen back. Guys, in case if I lost the connection, okay, just please stay there. I get back connected again, okay? Okay. It seems that it should be found. Okay. Are you still there?
Yes.
Okay. I don't know what happened to my screen. it vanished suddenly. Okay, as I said, I factor 1 over 20 first. Then the thing is that I come here, say it's equal to, I put my 1 over 20 here, and I try to go ahead to simplify the terms, and I know that my 1 over 20 is at beginning of all those terms there. Okay, the thing which I do, first of all, I simplify this term, which is to the power 3. I know that if I simplify that, I get what? I get first expression, x to the power cube plus 3 times x squared delta x plus 3 times x delta x to the power 2 plus delta x to the power 3. This is going to be, I should say, the expansion of the term which it involves power 3. I mean this term. And now I continue with the second term. I know that I have 2. I'm just going to multiply 2 beforehand. I'm just going to I just take it to the power 2. I'm going to multiply 2 to each term. Then becomes plus 2 times x to the power 2. Then plus 4 times x times delta x. Then plus 2 times delta x to the power 2. Does it make sense? I have, for this term, I have x squared multiplied to 2 becomes 2 times x squared. I have 2 times x delta x, then I have multiplied to 2, I have 4 times x delta x. Then at the end, I have just the term delta x squared, but it is multiplied to 2, then I have 2 times of delta x squared. Then I have something very important. I have the second term. For 1 over 20, I factored this out and I wrote it at the beginning, I should say, of my expressions. Then I have minus sign. It means that I take minus inside the parentheses and I take the terms where they are. Then it becomes minus x to the power 3 minus 2 times x to the power 2. Then minus for the third term plus 15x. Does it make sense? You see the minus sign goes to the first term, I have minus x to the power 3, minus goes to the second term, I have minus 2x to the power 2, and I have minus 2 minus 15 becomes plus 15. And I know that I have also the denominator, which is going to be delta x, which it needs to be pushed to 0 when we are going a little bit further. I'm going to write at the next line, I know that still I have the factor 1 over 20 at the beginning. Then I'm going to come here to just put the next line. To see that which terms are going to get more simplified and which terms they are equal that they can be vanished. Okay, guys, look at this one. I have minus x cubed. It seems that with the plus x cubed over there, they are very good candidates that I can just remove them because they are equal with the opposite sign. And also, I have other term. Look at that. I have minus 2x to the power 2, and I have here plus 2x to the power 2. And what else I have? That I can simplify that. It seems nothing more left. That's right. These two terms only vanish. Then I'm going to come here to write my, I should say, terms, term by term. But remember, here, the thing which I do is that in all the terms which is left, I have 3x squared delta x. I have 3x delta x squared plus delta x to the power 3. I have 4x delta x. I have 2 delta x squared, and I have plus 15x. These are the terms which is left, which it seems that, guys, I made a mistake. Guess where is the mistake? The mistake is here. Look at that. On the first term, when I take this to the power 3, and then I take this term to the power 2, I forgot to write here minus 15x. Look at that. Before going to these terms, I'm going to put it here. I had minus 15x. You see where is my mistake? I had to write minus 15x, which it comes from this one. Look at that, minus 15x. I forgot to incorporate it here. Then I jumped to write the other terms. Does it make sense to everyone? Do you see where did I go wrong?
Yes.
Yes? If that's going to be this case, you see that I have plus 15x here, and I had minus 15x over there, which these terms also, they are equal with the opposite signs, and they are just going to be vanished. Then, when I just want to continue, I'm just going to go ahead, and the thing which I do, because all terms, they have delta x, I'm just going to factor delta x at the very beginning and continue to write the terms. The first term which is left, then it's going to be what? Then it's going to be 3x squared, because delta x is factored out outside. Then I have plus 3x delta x, because 1 delta x is factored outside. Then I have plus delta x to the power 2, because one of them is factored outside. This term is gone. Then I'm left with plus 4x, which is going to be for this term. Its delta x is factored out. Then I have plus 2 delta x, which is this term. It's one of its delta x is factored out. Minus x cubed is gone. Minus 2x squared is gone with similar terms. And plus 15x also is gone. Then it seems that I have an easy life now, because I have fewer terms. And at the end, what I have, I checked at the denominator still I have delta x. I'm going to come here to continue. I know that I have 1 over 20 still remains there. However, you see that here, guys, that I have delta x, and I have delta x here, one at the numerator, one at the denominator, which it means that this delta x can get, this delta x can be just, I should say, eliminated. Then you get to the, I should say, of the ratio, and the only thing which is left for you is this term that we have. Let me write it a little bit up, because I need. Then it becomes 1 over 20. Then the terms which I have is this. It's going to be the term which is left is all inside the parentheses, which is 3x squared plus 3x plus 3x delta x plus delta x squared plus 4x plus 2 times delta x, which is going to be this term. I know that when I'm at this stage that I got rid of the delta x from the denominator with the delta x from the numerator, I know that at this stage, something is calling me. And that's that fact that I have to come here and I say, I'm just going to push delta x goes to 0. And if I do that, I get a very nice, easy form of my question. If delta x is going to 0, it means that whatever term you have inside the very last equation, which has delta x, look at that, this term has delta x, this term has delta x, and this term has delta x. When you push delta x goes to 0, it means that these terms vanishes because it becomes 3x times 0 becomes 0. Then you have plus something which is 0. Then you have 2 times something 0. Then these terms, they vanishes. Then at the end, you get a very nice, easy thing, which is going to be 1 over 20. The first term, which is going to be 3x squared plus 3x, which is the second term, this term, and plus this term, which is left, 4x. And now I'm going to love this term. Because this one is essentially the rate of the change, which I'm interested with this function. But let me double check to see that if everything is right. It seems that I just, give me 1 second. It seems that I missed something somewhere. Uh-oh. The 3x is there, correct? Okay, let's catch up with the terms which I had. Oh, I got it, guys. It is a little bit, I should say, discouraging. Look at this term. I said I just put minus 15x, but I was wrong essentially. I was supposed to just put what? 15x plus delta x, right? Then if you do that, when you expand that term, we have to make some corrections. Sorry guys, I just made a mistake with one term which I missed, and I screwed all those terms then. Then it means that when you, let me correct this one, when you just put minus 15x plus delta x, which is from that term, then you have two terms, minus 15x, which is cancels plus this 15x, and you get also what? Let me put that with the all the terms with this black, which it seems that that's going to be my correction. Then I get also one more term, which is going to be what? Which is going to be minus 15 delta x. Minus 15 delta x had to be added to this term, which it means that if I factor this out, then delta x is going to go there. Then I have minus 15. That's the good thing, which is I have it there. Okay, then it's going to be minus 15 here. I have this for x. Okay, it was 3x squared, that's correct. Okay, I got what did I go wrong then. Then look at that. I do not know why did I write 3x here. I didn't have 3x. I had 3x squared plus 3x multiplied by delta x plus delta x squared plus 4x plus 2 times delta x minus 15. Okay, now it's resolved then. Okay, then we factor delta x. The delta x is gone. Then the term which is left is 3x squared. It's correct. Three x squared is correct. I have 3x delta x is correct. I have delta x squared. This is correct. I have plus 4x. This is correct. I have plus 2 delta x. This is correct. And I have minus 15. This is correct. This stage, it involved, I just put delta x goes to 0. I have 3x squared I have 1 over 20, which is going to be essentially, this is the factor which I factor out. I have 1 over 20. I have then 3x squared. I have delta x goes to 0. It means that this term is going to vanish. This term vanish. I have plus 4x. This term vanish when delta x is 0. I have minus 15. And that's the correct answer. Oh, I love this one very much. Guys, you see that one mistake, which I forgot to put x plus delta x, replace it with the x, it causes so much trouble then. Then that's going to be the final right answer then. Ah, so much tricky simplification then. Okay, everyone is fine now? I hope I didn't just get you so much confused. Only one, I should say, tiny mistake. Anki, Laura, Sylvia, and Jasper. All of you are fine?
Yes.
Fine.
Awesome.
Yeah.
Guys, only we need 5 minutes to finish this. Then we just go for the break. Guys, just let me know something. Did anybody get to this stage? Did you get this equation? Anybody got that? Okay. And now, I'm just going to go over there, and at the second step, I just say put d over dx of m of x. What did I get? It was 1 over 20 x cubed, sorry, x squared. Oh, what am I doing? It becomes 3 times x squared plus 4 times x minus 15. And that's the second step. You know that when you just want to find a local maxima or local minima, the thing which we do is this: we take the whole term goes to 0. It means that then 1 over 20 of 3x squared plus 4x minus 15 should goes to 0. If you simplify that, you multiply both terms by 20, you get this equation, that 3x squared plus 4x minus 15 should goes to 0. Now, the task which we have right now then, the task which we have is to come to solve this equation. Okay, in order to solve this equation, x, it has a very easy, straightforward formula for it. X is going to be what? Is going to be minus b, which is going to be minus 4, plus or minus square root of b squared. B is going to be 4. It's going to be 16 minus 4 times a, which is 3, times c, which is minus 15, divided by 2a, which is going to be 6. Okay, let's simplify this term, which we get what? Which we get x equal to, we only need 5 minutes, guys. Sorry if you are getting tired, then we just go for a longer break this time. I promise to give you a longer break this time. Okay, now we have this one. We have minus 4. I'm going to keep minus 4 here, plus or minus. Let's come to, let's say, this one. I have minus 15 times 3 times 4. It becomes 45. 45 times, I should say, 4 becomes how much? I think 180. Let's put that in, I think it's going to be 180, but let's make sure that that's going to be a right answer. We have 35 times 4. Sorry, it's 140. Then we have plus 16. It's 156 divided by 6. Then we have x equals to minus 4. Okay, then we have a square root of 156. How much is that going to be, guys? The square root of 156. Let's get it. 156. The answer is going to be almost 12. Okay, it becomes plus or minus 12 divided by 6. Then for the x, we get 2 answers. For the x1, it becomes minus 4. Minus 12 becomes how much? Minus 16 divided by 6. And for the x2, it becomes minus 4 plus, I should say minus 4 plus 12 becomes how much? 8. 8 divided by 6. Then we have 2 answers for this equation. Okay, any questions, guys? Everyone is fine?
Yes.
Okay, it's going 3x squared plus 4x minus 15, then becomes minus 4 plus or minus b squared 16 minus 4 times 3 times 15, then it becomes 45, 60, I think. Let me see. Let me check. I told you it's going to be 180. When I just did that by my brain, I was correct. It was, when I did with the calculator, it was different. It's 180. Which is going to be around 9. 180, when you take the square root, it becomes around 9. No, it's 13. Okay, let's take this to 13. Okay, now x1 becomes minus 4 plus, I should say, plus 13 becomes how much? Becomes 9 divided by 6, and also minus 4 minus 13 becomes minus 17 divided by 6. These are the roots that we just get for this equation. Okay, and now let's go to the next page. put these ones. It's going to be my first root, my second root there. Okay, let's go back. Guys, are you tired now? Do you want to take a break, then we continue that? Because we have been working for 1 hour 15 minutes. Guys, we just stop here because we have been working constantly for 1 hour 15 minutes. I stop here because the next stage is going to be something, I should say, something which it involves a new learning for you. Then I just want to be fresh. Guys, right now this is sharp 10 a.m. Please come back by 10:15. We continue from here. Okay?
Okay.
Thanks. Because it's 1 hour 15, we are just working. Just come back in 10:15. We continue from there then. Fantastic, fantastic. Let's go back to the things that we were doing. Guys, it seems that I needed a break myself more than what you needed, because I just made a second mistake that I noticed that when I was having my coffee. And I noticed that, guys, the thing which I just put inside, I should say, when I was solving this, I just mistakenly, this one, it seems that I needed a break. I was tired. -4 times 3 times 15 is 180, becomes minus positive. Then I had to plus it, plus. And you see the 16 here also. I didn't see that 16. Then I had to say 16 plus 180. Then as a result, you get 196. Then the square root of 196 is 14. And that's the thing which it seems that I needed to take a break myself, because I just, for the second time, I made that mistake then. Then I have to just put here 14, not 13, because it's 4 times 15, it's 60. 60 times 3 becomes 180. That's what we have. Then we had also 16 here. We had to add 16. Then we get 196. Then the square root of 196 is 14, which we have. Then as a result, I have, for one of those terms, I have -4 minus 14, it's -18, divided by 6, you get to root number -3. And also you have -4 plus 14, which is 10. You get plus 10 divided by 6, which it can become 5 divided by 3. These are 2 roots that we are interested now. This root and this root. Okay, now we have 2 roots, and I'm just going to go there to the next page. Put it here. It's going to be for the first root, and this one is going to be for the second root. Okay. Now, the thing which I do here is that I just come here to write I should say my, what was that? By rate of expression, which it was d over dx of the m of x, which was 1 over 20 3x squared plus 4x minus 15. And here it's going to be my first root. My first root is going to be x equal to -3. And look at this one. It's going to be also, the second x is going to be what? The other root which we got. It was 5 divided by 3. Look at this one. We have, I should say, a priority for x equal to -3, because you will see that because the x-axis is towards that direction, x minus 3 is going to be before to x equals to 5 over 3 because x minus 3 is something which is less than this one. And you can expect here that, for example, somewhere here, you get, for example, your 0, x equal to 0 on the x-axis. Okay. We know that in order to find the sign of, or I should say, your instantaneous rate of change, we plug these values there. I know that these two values give me 0 because x equal to minus 3 and x equal to 5 over 3, these are the roots of this one. However, I have to just find the sign of this expression for the values which is from here to there. Imagine that I'm just going to pick up a line randomly which belongs to this portion of my x-axis, which in case it makes it very simple, I take something not too big. I get x equals to minus 4, which I can call that x is a xr. It means that x is a random one. Then what happens then? Then if I plug minus 4 into my expression here, then what do I get? I get, let's say, d over dx of m of minus 4. It becomes 1 over 20. It doesn't make sense. We only are looking for the sign. Minus over 20. Then we have 3. I have minus, let's say, 4 to the power 2 plus 4 to the minus 4 minus 15. How much does that become? Becomes 1 over 20. I have minus 4 to the power 2 becomes 16. 16 times 3 becomes 48. I have plus 4 times minus 4 becomes minus 16. And I have also minus 15 at the very end. Then how much is that going to get inside, I should say, this parenthesis? I get some...
I can learn to understand you much better if I can get familiar with the way you talk. I need your permission to help.
Okay, what is that? Okay, now look at that. Then I have also, look at that. Minus, I should say, 16 minus 15 becomes how much? Becomes minus 31. 48 minus 31, it is what? It is 17 plus 17 divided by 20 because I have this one 20 there, then I get something positive. Then it means that the whole, I should say, sign here from minus infinity to go to x minus 3, it's giving me a positive number. Does it make sense to everyone?
Yes.
Awesome. Then now, I'm just going to go to, let's say, the other term here. The second interval, it is something between minus 3 and plus 5 over 3. I know that for these two terms, I get 0. That's why I have this bold 0 there. But I just want to see what is going to be the sign of any random value that I pick up from this interval. I get x equal to 0 because that's a very convenient choice. If I put x equal to 0, what do I get? I get d over dx of m equal to 0. Then I plug 0 for whatever I have. Then I have 1 over 20 times 0 plus 0 minus 15. That's the negative number, correct? Then it means that as a result, this interval, which between minus 3 to plus 3, 5 over 3, gives me a negative number there. Now, I come here, I know that after x for this interval, which it means that x is standing between 5 over 3 to plus infinity, I pick up a number, random one, which is going to be something very easy to calculate this. Imagine that if I get a random number in that interval as x equal to, let's say, for example, 2. X equal to is going to be slightly standing on this part because it's essentially like the 6 over 3, and it means that it's standing at this interval. Then I come here to say that what is going to be the sign of d over dx of m f is equal to. You can pick up 3, you can pick up 100, you can pick up 1 million, but it depends how it's going to make your life easy. Then as a result, if I get 2, I plug 2 inside the equation, then I get 120, then I have 3 to the power 2, 2 plus 4 to the power to the 2 minus 15. What is that going to become? Becomes 1 over 20, which is not very important. I have 3 times 4 becomes 12. I have 4 times 2 becomes 8 minus 15, which is always a positive number because 12 plus 8 is 20. 20 minus 15 is 5. 5 divided by 20 is 1 over 4. Then it's positive. Then it means that for whatever you have a positive number there. Does it make sense to everyone? Everyone is fine? Yes?
Yes, sir.
Okay, and now, awesome. Guys, look at this one. This one is very crucial. Sometimes you have 3 roots. In the exam, I may give you a function which you have 3 roots of it. Then you see you have 3 stops. Here we had 2, we had x equal to minus 3, and we had x equal to 5 divided by 3. And look at here. What is going to be? Give me 1 second. The music was too loud. I had to turn it down a little. Look at that. And what's going to be the best strategy in order to find the local maximum and local minima? Look at this. For the first part, here they have a positive sign which stands between the interval between minus infinity all the way to go to the x minus 3. It means that the slope of a tangent line at any point on the graph of the function is going to be positive. And that's the geometric interpretation. A cartoon-wise is going to be this one. Because I have something positive, I know that I'm going to be happy. That's the smiley face for this interval. For the interval which stands between minus 3 to plus 5 over 3, I have the slope of the tangent line at any individual points on that function, negative. And that's the geometric interpretation. The negative sign, it means that I have a crying face. I'm not happy. Let me erase this part. And I go here also. And I see that for the points, the interval, which they are standing between, plus 5 over 3, going all the way to plus infinity, I have the sign, it's going to be positive. The geometric interpretation of it is essentially like that. You say that I have a positive sign, it means that the slope of a tangent line along any points of the graph is going to be positive. And also the cartoon wise, you know that because you have a positive, it's going to be a smiley face. And now let me erase this one because I do not need that anymore. Okay. And now Let's come here to decide which point is maximum, which point is minimum. Okay. The quotient stands for this point, the first critical point, and the second critical point. What are they gonna be? Okay, for the first one, we are moving from the positive slope to a negative slope of a tangent line. Or we are happy because we are top, we are beating everyone, we are top. Then we become suddenly sad. It means that we are moving down. It means that this critical point should have been the maximum one, because from the maximum you go down, then you become sad. Then the critical point xc equals to -3 is a maximum point. And now, the point which I have here, which is +5/3 as another critical point, I have from the area which the slope of a tangent line is negative, then it suddenly becomes positive. Or you can think of the case that you have a crying face, you are weeping, you are crying because you are so bottom. Now suddenly you become happy because it means that you are moving up. Then it means that this critical point should have been the minimum one. It was the minimum that you were sad. Now suddenly you become happy because you're moving up. It means that this point should have been the minimum one then. Then essentially it means that these points then, which critical point was +5/3, should have been the minimum points in your function. Correct? Everyone, is it fine for everyone? Do you have any questions?
No.
Nobody has a question? Lara, Anki, Jasper, Sylvia?
Nope.
No.
Everybody's fine. Then now you
Fine.
saw that what is going to be the procedure if you have more than one critical point, right? Okay. Now, the thing which I want to do is this now. I'm going to come over here to, I should say also to plot it. I know that I should have 2 points, -3 and 5/, I should say 3. I'm going to come over here and plot this function. I'm going to stop sharing and I'm going to go to share with you. I should say a graphicing tools which I have, which is going to be the Desmos. Everybody sees my Desmos function, Desmos application?
Yes.
Awesome. Look at that. I have m of x, which is going to be my function. I had 1/20. Then I have the parentheses open. Then I have x to the power 3 plus 2 times x to the power 2 plus, no, minus 15x. Right? This is going to be my function. Look at this. That's essentially the function we plotted it. You see that we have 3 intercepts because that's the polynomial of degree 3. It means that we have 3 roots at these points, which is 3 and the origin and the point -5. You see that the function intersects with the x-axis. These are going to be our roots. Because we have a polynomial of the degree 3, then we expect to have maximum of 3 roots, that it has become an intercept with the x-axis. Now, also, you can see our maximum and minimum points that we got. Look at this one. This point here. You see that? With the coordinates -3, 1.8. We got this point as a maximum without knowing its graph. Do you remember that? Right, everyone?
Yes.
Then look at this. It's also when you plot it, you see that this is going to be your maximum point. And also, you see this is a maximum because we call that the local maximum. You see that the function, it's the tangent of, or the slope of any tangent line to that point becomes 0, which it means that that's going to be a horizontal line. And also, look at this point, which is going to be the minimum point, which we got that it's going to be equal to 5/3, or you can simplify that to 1.667. You see that that's the minimum point. We know these ones. We learned these ones based on the analytical solutions which we had. But for a final point, before we go to the break, because we have to be here present by 11 to just go for the mathematics lab, which we have. Remember this, guys, that we can say, why do we call these points maximum or minimum? Although, if we say this point is going to be the maximum, essentially we mean that it's going to be the maximum, it's going to be the highest value that you can read of the function along the y-axis. But you may come to ask yourself, why do I call this point -3 and 1.8 a maximum point, as long as, for example, you can find a point here like that. Look at this. For example, 0.5. For example, 0.5. Or for example, I go up there, I get point, for example, 6 and 9.9. The value which they create is much bigger than the value which I have for that point. That point, the maximum happened. Please listen to this very carefully. It's very important. Look at this. You see that at the maximum point that we call it local maximum, we have, I should say, the value of the function is going to be 1.8, but we can find another point, for example, 0.6, which it gives you, for example, the value of 9.9 or almost 10. Then we see that we had a higher value of a point, at least for 6, that it gives a higher function. Then why do we call this point, I should say, the maximum? Because the question which I'm going to answer you at this stage is that we may have bigger values of the function which are going to be much higher, and we may call them global maximum. It means that, for example, you have local, it means that your scale is going to be small. You have global, that your scale is going to be too big along the whole function. But the point is that your maximum and the minimum happens when the tangent or the slope of a tangent line is going to be 0. Then that's why we do not call this point, for example, 6 and 9.9 a maximum, because at this point, the slope of a tangent line is not going to be 0. And that's the reason. The same argument for the minimum. We say that the minimum happens at x equals to 5 divided by 3, or 1.66, but you can come here to see a different point. For example, -7.5, which it gives you a more minimum, -9. -9 is much smaller than -0.74. Again, the same logic, because we cannot have the slope of a tangent line anywhere 0 except this point, then that point is becoming our local minimum. Does it make sense, everyone?
Yes.
It is a very important conclusion and interpretation that we can draw. Very important one. Please write it somewhere because it's the key and the golden key for the lessons that we learned for this week. We may have many other points as maximum or minimum, but the local maximum or minimum happens where the tangent of the slope of a tangent line becomes 0. And that's a distinguishing fine line for our analysis. Please write it somewhere. It's very important. And by solving this, essentially, I have to say, they are fully done with the chapter 2 of the book, which it was the average rate and spontaneous rate of change, except the fact that tomorrow we also have a quiz of this chapter. And we are done. Nothing more is left. Guys, any questions?
No.
No one has a question? Okay, now, guys, time right now is 10:43, 10:42. By 11 a.m., we are going to run our very first session of our lab sessions in the math. I'm just going to come up with it's a beautiful name. I'm going to call it with the name. Tell me if you have any idea. Then as a result, we are just going to go for the break now. We should be here sharp by 11. Please make sure that when you come back by 11, you'll be able to run either your R Studio or R software. Have it open on your desktop. By 11, we have a tutorial. Then we just, if you have time, we just go to the R to do some demonstrations then. For Lara or Sylvia, if you do not have the R Studio, R is fine. Just run the R. For Anki and Jasper, as you just installed the R Studio, you can just move on with the R Studio. You have both options then. Then guys, it's now 10:43. Please be back here. Take your time right now for the break. During your break time, make sure that you have the access to R or R Studio. Be here sharp by 11. We run our first lab sessions by 11 a.m. Okay?
Okay.
Awesome. See you all back by 11.